A steel of diameter 1.0 millimeters and length 2.4 meters support a mass of 6 kilograms. If the extension produced is 0.96 millimeters, calculate the Young modulus of the steel. Take gravity to be 9.8 meters per second squared. Okay, let's solve it. So this is our solution. The diameter, which is D, was given to be 1.0 millimeters. So converting it to meters will be 1.0 times 10 exponent minus 3 meters. Okay, and the length of the steel is 2.4 meters. And the mass, which is M, of the steel is 6 kilograms. So 6 kilograms. Okay. And the extension that was produced, so E is 0.96 millimeters. So this will be 0.96 times 10 exponent minus 3 meters. And the gravity, which is G, was given to be 9.8 meters per second squared. And we are to calculate for the Young modulus of the steel. Okay, let's first of all calculate for the force and also the area before we proceed with the calculation. So the force, which is F, is equal to mass and the gravity. So this will be equal to the mass is 6 times and the gravity is 9.8. So by using the calculator, 6 times 9.8, this will give us 58.8 Newton. Okay, so the area, the formula for calculating the area is pi d squared over 4. So this will be equal to pi times the diameter, which is 1.0 times 10 to the power negative 3 all squared all over 4. Okay, let's use a calculator. So this will be pi times 1.0 times 10 to the power minus 3 all squared divided by 4. So this will give us 7.85. So 7.85 times 10 to the power negative 7 meters squared. Okay, so we can now calculate for the Young modulus of the steel. So the Young modulus of the steel, which is E. The formula for calculating Young modulus is stress over strain. So strain. Okay, so E is equal to, the formula for calculating stress is force over area. So force over area all over strain is extension over the length of the steel. So this will be equal to force times the length of the steel all over the area times the extension. So therefore the Young modulus, which is E, will be equal to, we have the force to the 58.8 times the length of the steel, which is 2.4. So 2.4 all over the area of the steel is 7.85 times 10 to the 10 to the power minus 7 times the extension, which is 0.96 times 10 to the power minus 3. So E, which is the Young modulus, will be, let's use our calculator. So 58.8 times 2.4. This will give us 141.12 all over 7.85 times 10 to the power minus 7 times 0.96 times 10 to the power minus 3. So this will give us 7.536 times 10 to the power minus 10. Okay, so the Young modulus of the steel will be equal to 141.12 divided by 7.536 times 10 exponent minus 10. So this will give us 1.87 times 10 to the power 11 Newton per meter square. Please don't forget the unit for your modulus. It's Newton per meter square. Thank you very much. Please like, share, leave a comment. Once again, subscribe or follow for more. Bye bye.